Okay, so we're going to talk about two topics today. We're going to finish off subcontracting, and then we'll talk about another last design pattern for the course, which is also very interesting. Okay, let's first of all review what we got for the subcontracting quickly. Okay, I want to review quickly. There's only a few things to mention. Basically, we talk about different Boolean conditions over here. Basically, we got P1 and P2. Let's say they're being used as preconditions. Okay. And then we also talk about Q1 and Q2. Let's say they're used as postconditions. Okay, but P1, P2, Q1, and Q2, they are all Boolean conditions, right? Okay, so now let's just remember. When I say something like, if I say P1 as a precondition require less than P2, that would simply means P2 implies P1, right? So that means whatever that is required by P2. Whatever that can make P2 true, that can also make P1 true. Okay, but maybe there's more values that can make P1 true. Okay, that's basically what we said yesterday. Okay, an example would be, you can see x larger than or equal to 0. Oh, sorry, let me say that again. X larger than 0 implies x larger than or equal to 0. Because you can see somehow P1 is more tolerating. For example, you can see the value x equal to 0 is actually allowed. Okay, good. That's what we said yesterday. You can review that part. And then when we talk about postcondition, we talk about ensuring something. We say Q1 ensures more than Q2 if somehow Q1 implies Q2. Thinking this way, if you think about Q1 being the postcondition for a subclass, so that means whatever that can be true, that can be satisfied by Q1 is guaranteed to also satisfy whatever that's expected for Q2 that's in the parents. Okay? So now, let me just say one more thing before I move on to examples. Okay? So now, over here, something that requires less should be in the subclass. Okay? And something that ensures more should also be in the subclass. Okay? Now think about this kind of a pattern a little bit more, okay, with examples. Let me say, again, over here, that's kind of the picture you want to have, right? So when you declare a variable, let's say my phone, statically, again, there should be a plus here, statically is a smartphone, okay? You have some precondition here, you got some postcondition over here. Again, this might be, maybe consistent with what I said over there, okay? Let's say this guy here is P1, and this is P2. And over here, this is Q1, this is Q2. Okay, the precondition and postcondition. So what you really want to prove. So a typical question I can ask you on the exam would be, given P1, P2, and Q1, Q2, are the current design appropriate? Okay, so what you're going to prove is, number one, you want to prove that P2 implies P1, right? P2 implies P1. So P1 is weaker, basically. Okay? And number two, you want to prove that Q1 implies Q2. So somehow Q1 is stronger. So whatever that can be true for Q1, that's also satisfied by Q2. So you have no surprise. Okay. I'll just go a little bit quickly for the review, but you can definitely refer to yesterday's lecture. And before I go to the smartphone example, which we talked about yesterday, okay, I'm going to use the contract redeclaration rule to talk about it. Okay, just to remind you, for this particular contract over here, let's say that's the precondition over here in the parents, which is level larger than or equal to 10%, right? And this is the precondition in the subclass. So you say level over here larger than or equal to 15%. Are they appropriate? What should you prove? You will simply try to prove, is it the case that level larger than or equal to 10%? If that is true, is it necessarily the case that level is larger than or equal to 15%? Not necessarily, right? For example, 13%. That's the example we talked about yesterday. So now, if you got design like this, it's not appropriate. That's how you judge. So now, what happened at the runtime? IFO decided that when you put some precondition over here, it can be either weaker or it can be stronger. When you put a stronger precondition over here, in order to not to create any surprise to the user, what they will do is they're going to disjoin the precondition together. Let me show you, okay? So what I want to do is I want to give you two examples over here. Okay, let me just copy this guy here. Okay, and then the post condition will be a similar idea, so I don't need to repeat. Okay, so what I want to do is let's remember ourselves. So this guy over here is actually weaker, and this guy over here is actually stronger. Let's call that version number 1. I'll give you another version that's slightly different. Okay. Let me go back to the slides over here to remind you. If you want to declare precondition again in the subclass, you gotta say require else and ensure then. The reason they chose the keyword like else and then is because you got or else and then for the short circuit, like what I said yesterday. Okay, that part is fine. Okay, and then when we actually want to evaluate precondition at the runtime, so now this is the original precondition in the parent class, and that's the new precondition in the child class. So the new precondition here can either be weaker or stronger. Well, what's going to happen? Let's see both cases. When the new precondition is stronger, design-wise, it's not appropriate. But what's going to happen, right? Let's see exactly this example over here. Apparently, you can see here we got a stronger precondition. We know that it's not appropriate. It's not appropriate, but it will compile. You can still run. Okay. So now let's talk about runtime. At the runtime, what's going to be checked will be whatever that's in the parent class, which is level larger than or equal to 10%. And then I'll just copy this first. And the subclass is level larger than or equal to 15%. What they will do is they will disjoin them or else. And because of short circuit, if this part is already true, you don't bother with the right-hand side. It will just be true overall. You only evaluate the right-hand side when the left-hand side is actually false. Okay, that's kind of the short circuit. Okay, so now let's talk about the case. Let's say 13%. 13% conceptually is going to give you a surprise, right? Because 13% can satisfy, the 13% can actually make this guy over here true, but 13% when you try to evaluate this guy here is going to be false. So that's why conceptually it's going to give you a surprise. But now, how do we get around with that at the runtime? When you try to evaluate using or else at the runtime, you're going to get true at this part. As long as it's true, do we need to bother with the right-hand side? We don't. So the whole thing will just be okay, just be true. So in some way, even if you try to strengthen the precondition, like here, level larger than equal to 15%, even if you do that, it's not appropriate, but it has no effects at the runtime. Because when you put that together with the disjunction, the weaker one will just be true anyway. So you don't get a chance to evaluate. Yes, question?
Specific for IFO or is this for all object-oriented languages?
Good question. Remember, decide by contract somehow is supported natively in IFO. That part is unique. And of course, we'll still talk about contract evaluation. So indeed, that's specific to IFO.
So like, you get used to writing them wrong like this, and you don't get problems when you try to do it again in another language, you're going to get like runtime exceptions.
Yeah, that kind of stuff. So you know what? Oh, okay, that's a good question. So what would be the take-home message from this particular lecture? Apparently, most of you will not program in IFO anymore. That's true. But the take-home message for this is when you try to design your precondition or postcondition, you want to make sure you can maintain the substitutability, right? So that's the principle that applies to any OO language. So substitutability. In order to maintain that, you want to make sure your design for the subclass precondition should require less. And also, the postcondition in your subclass should ensure more. That's the principle. But how exactly they got evaluated depends on the language you have. Okay. Yeah, good. Jordan.
So why wouldn't we get a contract violation? Because essentially we're making an error here, right, in the design, since the subclass won't accept 50%.
Yeah, that's true. But somehow I would say it's more like a design decision. Okay, design decision for IFO is somehow you're trying to put two things together here. You're putting decide by contracts, also inheritance all together. You're right. One possible design decision is if you're violating the subclass precondition, you should give a contract violation. But somehow the IFO's way of thinking is when you actually got these two features over here. When you got this version, this feature and this feature, we're talking about the same feature. When you actually got one precondition here and one precondition here, you wouldn't treat them in isolation. It's not like a dynamic binding, basically. Maybe what you're coming from is you're more thinking about dynamic binding, because if the dynamic type is actually iPhone 11 Pro, you simply call this version only. But somehow, when you think about parent class, you should inherit something from there. Somehow you will inherit whatever precondition you have in the parent, but how do you inherit them? That's the question. So do you inherit them by using conjunction? Do you inherit them using disjunction? That's more like a design decision. Yeah. Anyway, I hope that kind of addressed your question. Yeah. Okay. Guys, that's the first version I would like to talk about. Okay. Again, the first version here, if you happen to get a stronger precondition, which is inappropriate, because it violates substitutability, make sure you understand that part. What's going to happen at the runtime is the stronger one on the right-hand side simply has no effects, because the left-hand side, which is weaker, is already true. Okay, that's how they get around with violation. Let's talk about another example. Shady is not here today. He asked me that question yesterday. Okay, let me put it here. What I will do is I will give you the same example over here. So let's try a more appropriate design, okay? Which means the precondition over here should be weaker. Let's say for some reason iPhone 11 Pro has now been more efficient on energy consumption. So now it can get the reminders even if the battery level is even lower, let's say. Okay. It used to be 10%. What about we say 5% over here? Let's say that's a new design. Okay. Apparently, how do we judge if this is appropriate? You got to prove that level larger than or equal to 10% implies level larger than or equal to 5%. Is that the case? Indeed. Okay, that's good. Okay. If it is the case, what's going to happen at the runtime? That's going to be an interesting bit. What's going to happen at the runtime is like this. Let me show you what exactly. Let's say we have P of type smartphone. And then we simply say create dynamically is going to be a iPhone 11 Pro. iPhone 11 Pro over here, P.make. Let's say we are trying to use the phone somehow. Let's say at this point, the energy level is simply just, let's say, about 6%. Okay? Just around this point. First of all, 6% is going to fail the parent's precondition. Agree? Somehow it's going to fail. However, the subclass is able to give, because it requires less, so it's now going to be able to tolerate that. Let's see exactly how it's going to happen. It's going to be 6%, assuming that. So now if I say P dot get reminders. Now question for you. If I try to execute this particular query call, am I going to get a contract violation? No. Disjunction, exactly. That's exactly right. So at the runtime, what's going to be checked is like this. It's going to be, first of all, whatever it is here, level larger than or equal to 10%, or else, also here, that's a new design we have, level larger than or equal to 5%. So now we talk about 6%. 6% over here is going to make it false. So that means we have to evaluate the right-hand side. We have to. In that case, 6% larger than or equal to 5% will be true. So we still get true overall. So we don't have a precondition violation. Okay. So you can see that somehow it's pretty nice, to actually guard you from some particular violation. Okay.
Professor, where do we specifically implement the disjunction or conjunction?
So the disjunction and conjunction we talk about here is implicit. You don't implement by yourself. Yeah, remember, something very similar. Okay. Remember I mentioned before, if you have, let's say, a feature F, and then you got require. If you simply say precondition 1, precondition 2, implicitly, you're really saying you must satisfy both P and P1 and P2, right? Implicitly. So you don't really implement the conjunction. It's just there. Similarly, if you say ensure over here, if I got Q1 over here and Q2 over here, implicitly, it's also like a Q1 and Q2. They must be satisfied, right? So the contract redeclaration rule to say the precondition or else, the children's precondition, that's or else part is implicit. Okay. All right, given that, we're going to see a little bit more. Okay, so this is basically what we said. So let's say over here, if the original precondition over here is already true, right? If it's already true, doesn't matter what the child's precondition is, it's guaranteed. There's no surprise for expectation. Okay, that's why I said it over there. And it'll be very similar if we talk about post-condition. For that part, I can leave that to you. For the post-condition, that's more interesting. For the post-condition here, I'll just mention one thing to you. Okay, when we talk about post-condition, let me show you the thing here. When we talk about post-condition here, let's say you got Q2 and also you got Q1. What's going to happen is you're going to check at the runtime Q2 and Q1. Oh, sorry, yeah. Okay, Q2 and Q1. Okay, let me just say it again. Sorry about that. So you got Q2 over here, and also you got Q1 over here, right? So what you check at runtime is Q2 and Q1, more precisely, and then. So that means not only that Q2 must be the case, and also Q1 must be the case. So what's the intuition over here? The intuition is if somehow Q2 is already false, according to short circuit, do we need to bother with the right-hand side? We don't have to. Intuitively, what that means is if the parent's expectation on the post condition, like a Q2 here, is already false, then there's no way you can get around. You should just signal an error. Okay?
So for post conditions, they always model and relationship, and preconditions model.
Correct. So when you talk about inheritance, when you talk about precondition inheritance and post-condition inheritance, it's either or else or and then. Okay. All right. Okay, so that's exactly what I meant here. So if you look at that over here, the parent's post-condition and then the children's post-condition here, right? If the parent's post-condition is already false, so that means you're violating the substitutability because we got a surprise from the parent's expectation. Overall, it would just be a false post-condition violation. Okay? Guys, are we okay with this? Okay, think about it. Okay, we can definitely talk about this more when later on we do the review for your exam later. Okay, I want to talk about two more things, which is very easy, okay, before we go to design pattern, which is much more exciting. Okay? Now, I want to ask your opinion over here. Let's say this particular scenario. Let's say we have a class called foo, and we have a subclass called bar. Okay, bar inherits from foo. And then, let's say this. In the case of foo, we don't have a precondition. In the case of bar, we have a precondition called new pre. Okay. So now, the question for you is, in this case, what would be implicitly the precondition for foo? I heard true, I also heard false. I'll say the question again, no worries. So we have two classes over here. We got foo and then we got bar, right? In the parent class foo, we don't have a precondition. In the subclass bar, we do have a precondition. We say it's new pre, okay? So now, at the runtime, how about this? At the runtime, are we going to check true or new pre? Or are we going to check false or new pre? Okay, one more, okay? Before you have any say, hopefully that can help you think about it. Again, that's the example we talk about. Okay, we want to make a decision. The question is, at the runtime, we got two alternatives over here. Either it's going to be true or else new pre. Or it's going to be false or else new pre. You got either one or two. One or two? I heard one. Anybody who thought there should be two? It's okay. There's no democracy here, right? Okay, so now, if you say two, why would that be two?
Okay, so my understanding is if the parent class's precondition is false, it means it allows no values in, and then the subclass allows more Or more values in it. So like it's a weaker precondition because it has more like values that it allows in.
But the problem is, if you think about it, if you actually got this option over here, I can tell you what the problematic thing is. If you are treating this as false, so that means this particular feature here conceptually is useless, right? So that means over here, f, when the client declare static type as foo, then that means you can never call f. So that's kind of a why. It's not quite. Yes, I will take question. Yeah. That's also correct. That's also correct. Okay. Let me say this. Okay, there are two ways you can look at that. So the correct answer should be over here. Guys, please. So that's the correct answer. When you have no, first of all, when you have no precondition here, you can think about it simply means I can accept anything for the parent class. Okay. Implicitly, it simply means require true. That's one way to think of it. Okay. Another way to think of it, why would 2 not be the case? Because if 2 is the case, in that would mean the feature the client is actually expecting is useless because if there's no input value that would be allowed by f. Okay. This one is a little bit unintuitive. Okay. I'm just trying to say when you actually didn't declare anything as a precondition for the parent class, it's as if you declare true. That's my point. Okay. So now false will actually mean useless f at the full level, which is parent class. Okay, let's do a little bit example here. Let's say, for example, somehow I declare new pre as x larger than 0. So in the subclass, I'm saying I will only be able to call f if x is larger than 0. Okay, so now if I try to conjoin them together, what's going to be the case? Just true, right? So at the runtime, you're only going to check true or else x larger than 0. In that case, you will actually never try to evaluate the child's precondition because it's always just true already. Yes?
Like, I understand why it should be true, but doesn't this also violate the whole thing where like the precondition of the child shouldn't be stronger than the precondition of the parent?
So that's true. So that's inappropriate design. Yeah?
That's like I'm not confused like why.
No. So first of all, we should really know that when it is definitely possible when some user doesn't declare any precondition for foo, but they somehow declare some precondition for bar. They can do it, we cannot stop them from doing it. However, we're trying to justify to say, if you do it, it's inappropriate. At the runtime, x larger than 0, as we said before, has no use because it's already true on the left-hand side.
So if the parent class has no precondition, there's no point putting any precondition for the child.
That's no point. Yes, exactly. That's exact. So what you're saying is right. The take-home message for this example here is, if somehow in your design, if the parent class has no precondition, so that means you're saying all the descendant classes should have no precondition as well. That's basically the message from here. Let me write it down. If in the parent class there is no precondition, so that would simply means no preconditions in all the descendants. Precondition in all descendants. Okay? Guys, are we okay? Okay.
So I also think about which file else and the or is some almost related, and the insert them and is related.
What do you mean?
I mean, okay, you say that require else. I think it's a little bit related to or.
Require else, yes, it's or else, basically. Whenever you declare or else, when it's checked at the runtime, you would say whatever that's in the parents class precondition or else the precondition in the subclass.
And insert them on and related.
Yes, ensure then is related to the and then. Yes, that's correct. We'll see that. We'll see that.
I think one is must be true
Correct.
we know the left-hand side, but for the number 2, we don't know.
For number 2, it's simply inappropriate. For number 2, yeah, logically speaking, yes, if the left-hand side is already false, right, then you still have to evaluate the right-hand side in order to know. But we're saying that having the precondition here being false is simply not sensible.
Yeah, it's not appropriate than the first one.
Correct. Okay, guys, let's see another one, okay? So now let's say in the parents class, we don't have a postcondition, okay? And then in the child class, we do have a postcondition. That's kind of interesting, right? So now, first thing first, what would be the equivalence in short in the parent class implicitly? Would that be true or would that be false?
We don't know.
What do you mean we don't know?
Well, if it's true and then it should be weak, so I don't know.
Okay, let me write it down. Question is, implicitly, what would be the in short? Implicitly, right? I didn't do anything. I'm just saying implicitly, okay? So now, one could be, it simply means false. False, and then, when we evaluate the runtime, and then, new post, right? Number 2, or it can be true. And then, new post. Okay, either 1 or 2. Okay, think about what's going to happen at 1. If 1 was the case, let's say, what does that mean? That means, wow, you can never have any descendant classes, actually. Because when you try to evaluate at runtime, you will always get false for the post condition, because you already got false over here. Okay, so 1 cannot be the case. The consequence of 1 simply means never succeeded at runtime. Because this already false, so always evaluate false. On the other hand, if you look at option number 2 over here, implicitly, if that simply means true. So what does that mean? That means at the parent class, they're being very tolerant on the supplier. I'm saying I can accept anything after the feature is executed. But somehow in the specialization version, in the specialized version in the child class, we're saying that now we're going to ensure more. For example, iPhone 11, let's say for a smartphone, they don't really, I'll give you one example here. Again, we have smartphone over here, and also we have iPhone over here. We still talk about get reminder, let's say. Get reminder. And we also talk about get reminders over here. And then we talk about ensure. Okay? And also we talk about ensure. Let's say, for example, slightly different from the example you saw previously. Let's say for the get reminders in the smartphone level, we don't say any post condition. Basically, the return type for get reminder is simply just a list, right? If you recall. It's simply just a list. So that means I just want to get some reminders. Whether the reminder is for yesterday, today, tomorrow, I don't care. You just give me a list. Even an empty list will be acceptable, let's say. But now the child class, we are being more specific about what we can offer for this particular instance. Over here, we might simply say all the reminders, all the events in today will be reminded. So somehow we are strengthening the post condition. Okay? So this actually makes a little bit more sense, because now it's like implicitly at this level over here, we simply say true. Like any reminder will be okay. But now in the child class, we are expecting the children to be more specialized in this particular post condition. Okay? So what will be the take-home message for this? Okay? The take-home message for this will be, okay, previously we say, if the parent class, there's no precondition, that means you shouldn't try any precondition in the child class. Now it's the opposite. Okay? If no post condition in the parent class, that simply means it is expected that some post condition will be added in descendants. Okay, that's another principle here. Yeah, I'm just trying to say, tell you, of course, when you actually do your design, just remember when you don't have anything in the parent class, what does it really mean? So you would know. Okay. Guys, are we okay? Okay, we're getting there. Just two more examples, 2 or 3 more examples, then we're done. Yes.
Can I ask a general question about expectation and making stronger distinguishing between the two? So does making stronger mean that you're doing, so when I say you make a precondition and postcondition stronger, you essentially do less because you accept less input? Essentially what that means is that by having a stronger pre or postcondition, do you have more expectation?
No, no. You have to think separately between pre and post conditions. By having a weaker precondition, that means you're being more tolerant on the input values. By having a stronger post condition, that means you're being less tolerant on the output. That means you're being a stricter clients. So you're expecting more from the supplier. That's what it means. Yeah. Okay? Yes?
So just to clarify, like, you know how you said like before else it was like if you check one and just the left side is true, then you're going to check the second one?
Correct.
So with the post condition, when you're looking at it symmetrically, like let's say for example, for this example, if the smartphone gives all the dates for today, the iPhone gives all the dates for today and tomorrow. The reason why it wouldn't work is because like let's say if we had like all the dates for today, it would check the parent first, it would evaluate to true, and then when you do the conjunction, you could also still get like tomorrow.
No, actually, you know what? Okay. Basically, you got to think about when would a client be surprised. A client would be surprised if some feature they used to be able to initiate, but they cannot initiate anymore. That's basically has to do with if you have a stronger precondition. However, the client wouldn't be so bothered if you can offer them more about the service. Let's say, for example, they want to get a reminders, they simply don't care what the reminder should be. But somehow in the subclass, you can say, I can offer you more. I'll give you basically reminders, not just randomly. I'll give you specifically for today. So I'll give you a better service. They wouldn't mind.
So if you do the other way, if you have like more specialized in the parent and less specialized in the child, it would give you values that you weren't expecting in the child class?
Yeah, so I would say maybe not to mix with expectation over here. Yeah, basically just think about when a client is using this particular type of objects, will they be surprised? All they have reference about is the contract in the parent class, basically. If the parents say, you can only call this particular F under certain circumstance, but now if the child class has more constraint on the input value, that would be a surprise. Okay. All right. Questions? Or you're fine? You mean for the post condition, or yeah, the child should be stronger. Yes, correct. Yeah. So apparently, you can see that. Yeah. Let me make it clear. First of all, we say that if you don't have a precondition there in the parent class, it's as if it's true. Okay? It's as if. Separately, yeah. So I would say try to think about them separately. When you talk about precondition between the parent and subclass, you talk about disjunction. When you talk about the postcondition between parent and subclasses, you talk about conjunction. Case by case, yes, for sure, yeah. But guys, don't worry. I'm pretty sure you will still be struggling when you study that. That's okay. That's what the review session is meant for. Think about it, okay? Okay. 2 more, all right? Let's say we do have the precondition over here, okay? But now we don't have any precondition over here. Basically, what I'm saying is over here, I have the original precondition over here, and then it's missing from here.
That is fine. That's fine?
Yeah, basically, it's basically like simply this guy here is just as if it's true or false. It turned out it should be false. That's a little bit tricky here, okay? You know what? Yeah, I'm pretty sure it's kind of unintuitive. Yeah, question first, yeah, before I get to there.
Pretty sure it's false. I mean, because if it was true, then the OR would just say it's true and will not evaluate.
Hmm?
If we replace false with true, then or would just say always true.
Mm-hmm. Okay, yeah, let me give you some intuition about here, right? I know it's kind of weird, okay. Before I justify why it should be false, let me try to justify why it shouldn't be true. How about that? Okay. Let me tell you why true would be very wrong. I'll give you one example. Okay, basically, again, we got different options over here, right? Number one, it would be original precondition or else over here, and most of you believe intuitively it should be true. Why would that be a bad interpretation? Anybody want to try? Okay, you first. Yes.
If the original precondition was false, and then it would be false or true, so it would still true. So it needs to be false, like it has to not be false.
But we talk about the precondition in the subclass, right?
If that precondition the child was true, if the original precondition was false, then that statement of the or else true will still be true.
Oh, you're saying how inappropriate it is, right? Okay. Let's try something that's not so extreme. Okay, I know what your point is. We might want to speak up first before I try. Okay, good. Let me try something not so extreme. Okay, slightly not so extreme. Think about the smartphone example again. Okay, but you're pretty much making the right point. Why true is not appropriate. Let's say original precondition again is the battery level should be larger than or equal to 10%. If I don't have any precondition in the child class, and if that should be interpreted as true, what does that mean? That means at the runtime, 10% larger than or equal to 10%, and simply this is true. Does it really matter what the battery level is? That simply interpreted this way. It's simply equivalent to true. So that means you can use the phone at any time. That part doesn't make sense because there should be some minimum precondition that's actually be preserved by the parent class. Somehow, you're saying you should be able to use the surface when it's larger than or equal to 10%. But somehow, if you go too much extreme to say it should be true, in that case, that means there's no constraint on the battery level at all. Okay, that's not good. Okay, so this is not appropriate because there'll be no constraint whatsoever on F. And remember I said yesterday, when you try to design your pre or post condition, you shouldn't really have one that will go to either true or false. You don't want to go to extreme. So what this will have is it's going to give you a precondition that's true. So that's going for the extreme.
Yeah, we know it is true because if for the or statement, if one of them is true, it must be true. But what do you mean not appropriate?
It is not appropriate because if you simply got a precondition being true, that means you can call the feature anytime you like. That's not good. Okay, questions?
Can I ask a question regarding the construction of objects in idle?
If that's not relevant to this, we better hold it off. Yeah.
Okay, the question is okay, sorry.
All right. Okay. Any other questions? All right. Are you okay with this justification here? Because in order for me to justify why false should be the case, I thought it might be easier. Think about why true is not appropriate. If you put true over here, so that would simply mean the overall, it will just be true always. You don't want to have a feature with no precondition for the child class, right? Okay.
Every object inherits from every object inherits from any.
Oh yeah, actually, if you look at any class, also there's some certain feature that also has a precondition.
Oh.
Yeah, you can look at it. Yeah, yeah. Mm-hmm. All right. One example where the feature does not have any precondition is something called out. Do you know the out feature? Yeah, out is like a toString in Java. That one has no precondition. All right, one more, okay? I'll just talk about different cases, right? How about this? Let's say this guy over here, I got my original post condition in the parent class and nothing over here in the child class. It would be as if what? Ensure true or ensure false? Okay? In order to justify why ensure true should be the case, right? So we're saying when you have nothing here, it's as if. you say ensure true. Let's talk about why ensure false should not be the interpretation implicitly. Let's think about it. Easy. Similar idea. Because in that case, it shouldn't be true over here because or else true will just give you true. You go to the extreme. So now if you say and then false, it's going to give you false, right? So now if you say original post condition over here, and then let's try the wrong interpretation. If we simply say it's simply false. In that case, does it really matter what this is? Doesn't really matter. So you basically end up having a service that would never be satisfied by the clients. That's too hard for the supplier. Okay? So now, this is again not appropriate.
So we are not constrained, right?
So not appropriate because no supplier can satisfy false. Okay? Because overall just be false. Okay? Yeah, think about this kind of manipulation of the logic, right? Okay. Think about it. We can definitely revisit, but just at least you get some intuition. Okay, one more example before we go to the design pattern. This one is slightly more intuitive. Okay. Class invariance. You can think about the intuition is easy. Because invariant is simply the post condition for every feature, right? So now, if I have invariant A in the parent class, and I have another invariant B in the subclass, how should A and B be combined together? Should I use conjunction or disjunction? Conjunction, because we use conjunction for post condition, so it makes sense to use conjunction for invariance. Let's just see one example, okay? It'll be conjoined, first of all. Okay, let's say this example here. Let's say we got a class called polygon, okay? And then we simply got an array of points being the vertices, let's say. And then invariant is simply a polygon should be at least should have 3 points, right? Okay? Otherwise it's a line or a single point. Let's say we have a rectangle over here, and then it simply inherits from polygon. And now we can somehow have a more specialized invariance over here. And then we say vertices that count equals 4. So now, when you have invariant, there's also a way for you to justify whether a class can be a subclass of another. So now, let's say at the runtime, okay? What will be checked for rectangle? You will check invariance, but is it only going to check this particular one, which is the vertices that count equals 4? It's actually going to check 2 things. It's going to check the vertices that count larger than or equal to 3, and then vertices that count equals 4, because it makes sure both are true. But to be honest with you, you can see this. Effectively, when you say vertices that count equals 4, it's a stronger one. So checking that will be enough. But anyway, it's more like about efficiencies issue. So what will be checked at runtime will be simply, you just make sure this and this just equal to 4. Okay? So now, let's think about one exercise for you. Let's say we got something called pentagon. Okay? Can pentagon be a descendant class of rectangle? Well, intuitively it doesn't make sense, right? But can you try to justify to me from the point of view of class invariance? Yes, please. Yes.
So because rectangle has a variant where it has to be 4, a pentagon will have 5. So then it would be
Yeah, you were basically saying vertex that count equals 4, and then vertex that count equals 5. That'll be equivalent to false. Okay? That's one way to justify, right?
Wait, I'm confused with that. Vertex dot count is greater or equal than 3, and vertex dot count equals 4. It becomes vertex dot count equals 4. And what if this one for the greater or equal to 3 will be 5? What could that be?
Basically, we're saying that in order for these two things to be true at the same time, it's equivalent to you're saying it's equal to 4. That's the only intersection between the two.
So
It must be 4. If it is simply equal to 5, then of course you evaluate to false, right? Okay, so how we justify to say pentagon, exactly what you said. That means when pentagon, you will say vertex.count equals 5, and then vertex.count equals 4, right? That's the invariant from rectangle. If you conjoin them together, you're going to get false. So that means your pentagon will never run. You always got class invariant violation. What's the take-home message for this? So that means when you are trying to put your invariant in your classes, you may want to think about, when I conjoin all the ancestors invariant together to the current subclass, are they going to evaluate to false? Maybe. If that's evaluated to false, it's very hard to debug, right? So you always get class invariant violation, which would be very unfortunate. Okay. Question? Yes.
So you said the invariant is like basically a post condition that gets checked after every future call.
That's correct.
So if we're thinking about it like that, are there any like discrepancies between like how we set up our invariants versus how we set up our post conditions?
Oh, so okay. Basically, your question is like this. What Boolean condition should be the invariant, whereas what should be the post condition? Easy. Well, I shouldn't say easy. I'll say it's a simple rule to think about. Okay. Let's say if you find that if there is there's a Boolean condition, so if there is a Boolean condition B, oh, thank you. I always forget. If there's a Boolean condition B such that B should be the post condition of every routine. Well, if you read the project description, routine means command or query, right? Okay. Command or query. If there's such a Boolean condition, for example, you found that after every post condition, I want to make sure a rectangle still remain to be of size 4 for its vertices, right? If that's the case, then that condition for single choice principle, they should be in a single place for class invariance. Okay? So that means B should be a class invariance. On the other hand, if you find that this Boolean condition B is only the post condition for just a few features, but for others it doesn't apply, then that should not be a class invariance. Okay? Yeah. All right. I believe we got a last slides over here. Okay, again, so this is just to summarize what we have seen in this lecture. Okay, basically every time when you talk about inheritance, you talk about parent class, you got child class. You got some precondition, postcondition in the parent class. You got some pre and post condition in the child class. Two things you have to worry about. Number one is, how do you judge if the design is appropriate? In that case, you want to make sure the precondition in the subclass require less, and the postcondition in the subclass ensure more. Okay, that's a kind of formulation. What about dynamically? What's going to be checked? That's something you should also be aware of. What we check is we're going to use disjunction to check the precondition. We're going to use the conjunction to check the postcondition. Okay, that's the last slides for the lecture. I'll take any question you might have, and then we'll go for design pattern. Yes.
So, Professor, when we don't have a post condition and we add a post condition to the subclass for parent class, that is okay because the post condition in the subclass makes essentially we're giving more to our client by constricting our output.
Yes, you definitely you should, whenever you create a subclasses, you should really try to add more post condition for sure, just to give more surface to your clients.
But the opposite is true for precondition.
For precondition, you don't want to. Yes. Mm-hmm. Any questions?
I don't know what that means. Original tree or new tree is checked. I'm just.
Maybe you want to review the slides a little bit and then come talk to me offline. I think that'll be better. So or means disjunction there, and then.
But I mean, original tree, arrow, new tree. How?
So this guy here is disjunction. Agree?
Yeah, it's just disjunction.
Check the disjunction of the two preconditions, and here you check the conjunction of the two postconditions.
Right. But for the static design, I'm not clear with that.
I suggest maybe you can ask me offline. So maybe look at the slides and then come back to me offline. I think that'll be better.
Office time.
Office hours.
Office.
All right. If no relevant questions over here, I will move on to the next topic. So this one here, again, we're going to solve a different kind of problem over here. Okay? And then to solve this problem here, as usual, we're going to present different designs. Then we'll try to criticize on that, right? We're going to read some diagrams and then think about some one-time scenario and then write some tests. Okay? That's basically what we're going to do. It's basically an observer design pattern, but eventually what we will get will be get into event-driven design. Okay? But anyway, don't worry about the terms for now. We'll just focus on what's going to be solved. Let's say this is something we would like to do. Well, for those of you who take actually all of you took a 1022, can you develop an app that will actually somehow monitor the weather and then actually return something? Oh, maybe that's something you can imagine for now, but that's okay. I'm pretty sure you can do it. But we'll try to do give you some sketch of how to do it. Okay? Let's say this. Let's say somehow we have some weather station over here. It will collect weather data about temperature, about pressure, about humidity, right? So these are the common measures. Let's see what the problem is. Okay, we got weather station, we got weather data, okay? So weather data is going to be turned into a class later, okay? Basically, we got different weather data objects. So we got temperature, we got humidity, we got pressure, okay? And then what we want to do is to say, we want to develop different apps. Let's say, for the illustration purpose, we have three kinds of apps. We have the apps for reporting the current condition, in which case we just want to know what's the temperature in Celsius and what's the humidity in percentage. Okay, that's the condition app. Very easy. But somehow, of course, you got to keep up to date what the current temperature and what the current humidity is. Okay. The number two, let's say we've got a forecast app. The forecast is going to somehow predict whether it's going to rain. For those of you who study physics, maybe you know, if it is a reduced pressure level, that means it's more likely to rain. Don't ask me why. Okay. So now, if you do a weather forecast, somehow if you find that if your pressure level actually reduces, it's more likely. I'm not saying it's guaranteed, just more likely. Okay. And you got another statistics app, and it's going to tell you what's the maximum, minimum, and average so far. Okay? I know, just different apps over here. Okay, any question about the problem itself? Okay, apparently one thing to observe. You can see for every kind of app, for each kind of the three apps over here, they kind of worry about different kind of data, right? You can see for condition app, they only worry about temperature and humidity. They don't care about pressure. Okay? For forecast, they only care about pressure, but not the other two. For statistics, they only care about temperature, but not pressure or humidity, right? Things like that. How would you design this? How many classes do you think we might need? Any idea? Just suggest something, that's okay. Do we need a class for weather data? We might need it, right? And since we got three kinds of apps, we better have three classes, right? If you want to make it fancier, you definitely can have maybe a super class called app, under which you got three different subclasses, right? That's also possible. Okay, I'm just saying that. Let's look at the first design, okay, which will be reasonable. Let me just move this guy here away so we can see the first design. Okay, the first design looks like this, and we're going to test it, okay? So now let's read the diagram over here, okay, together, before we see the code. The code itself is very straightforward, okay? So basically, we got a weather data class over here, where we got temperature, we got humidity, we got pressure, real numbers. Also, we got something called correct limits. Correct limit is like an auxiliary query, which tells you what should be the limits for each measure. And then we simply call the correct limits in the invariants to make sure it's also valid measures, okay? And then we got forecast, we got current conditions, we got statistics, right? Three different classes. And then tell me what it means when I say I have a client supplier label over here and I have weather data. What does that really mean?
Variable type weather data that's of type weather data
In where?
in each of the classes.
Yes, correct. Okay, again, if you are having trouble with reading this arrow, you better make sure you catch up, okay? We have a client supply label over here. So that means this guy over here is the client's and the class over here is a supplier. The client side must have declared something called weather data, right? I'll say weather data over here of type weather data. That's what it means implicitly, okay? And that's the case for every class over here on the client side, right? That's why we got client supplier labels, 3 of them identical. And then let's see a little bit more. You can see for all of them, we actually got a feature called display. Display and display. Display simply means I want to show what's the current result for this particular app. What's the current condition, what's the current forecast, whether it's going to rain, and what's the current statistics, maximum, average, and minimum. Okay, things like that. And one more thing to note. You can see for forecast, we only got current pressure and loss pressure. We don't worry about temperature or humidity, right? That's not our concern. Similarly, for current conditions over here, we only worry about temperature and humidity. We don't worry about pressure, okay? And for statistics, we only have temperature. We don't worry about the other two, okay? That's pretty much consistent with what I said, okay? Do you see any problem here? Huh? Why doing single choice principle?
This display is not being inherited from weather data, or it's not being inherited from
No, actually, you know what? In some way, you can think about the way we implement the display among the 3 apps are quite different because they got very different concerns. Yeah. Actually, to be honest with you, to be fair, you cannot quite see the drawback for what this design is by seeing this design diagram, to be fair. You cannot quite see it. But what would you like to say, please? That's okay. Let's say we have some mechanism to make sure they actually point to the same weather data. Yeah. I'll give you a little bit hints. Presumably, these are mobile apps. Every time, if you want to somehow get updates on the data, you have to consume some network usage, right? Some bandwidth. You have to spend some communication with the network. So now that means every time I want to display, maybe I will initiate display in my mobile app every 5 seconds or every 2 seconds, let's say, if I want to be very accurate. Is it really necessary to initiate display this often? Because every initiation of display is going to cost some computing resources. What I mean is, what if I try to initiate the updates on my mobile app, but there's really no updates? Then wouldn't that waste my computing resources? That's something you don't quite see from the design diagram. Let me say one more thing, and I'll take questions. What you don't see is somehow weather data and these guys over here, they might be geographically distributed. Geographically distributed. Which means you really want to avoid the number of calls on the updates in order for display. Okay? Let me go over a little bit code with you, and then we'll see exactly what I mean. Okay? And then we go to observer. So what I will do is I'm going to show you a little bit code over here quickly. Okay, that's a diagram we just went over. And then let's see this. For the weather data, we simply got 3 attributes. And that's you don't have to worry about exactly constraint R. I'm just saying some constraint over there, okay, on the limits of the 3 measures. And then you simply write the invariance over here. That's the important part, right? Have an invariance. And then I'll just show you one of the apps. The other 2 are very similar. Let's say we got forecast, in which case we only worry about the pressure. You can see we also maintain a reference to weather data. That's why you see the client supplier label. And then let's say when you try to initiate, actually, by the way, for those of you who took 2030 last year, yeah, exactly. That's exactly true. Around that time, I was teaching this lecture. I thought, why don't I just make it a lab for 2030? Anyway, but that's I would say sure, but I'm just saying maybe your app, even if the weather measure change so often, but still your app might actually do the update even more often, right? We just want to make sure you only try to update when necessary. That's the point. But you don't necessarily have to report like every Yeah, every so often. Maybe you should only report when the temperature drop more than 1 degree, right? Something like that. Yeah. Anyway. All right, so now, we got weather data here. We got updates over here. Okay, so now look at the update here. What the update would do is it will simply say, I'm going to say weather data dot pressure. You can think about when I say weather data dot pressure, even though it's only an attribute call. However, think about this particular call will involve certain network usage, right? We're going to connect to the weather data, which is geographically distant, and then we're going to get a pressure. So you want to make sure you only call the updates over here when necessary, when there's a significant, when there's a non-negligible change on the pressure that you care. Okay, that's my point. And then display. Okay, what you will see for every class is every time before you do the display, you're going to call the updates. So now, if you actually your app call display way too often, so that means you also have to call update way too often. That means you're wasting your resources. That's the point. Okay, I'm going to justify it to you quickly. Okay, so now for the actual coding, you don't have to worry too much, but look at that. Okay, basically saying if the pressure is reducing, that means it's actually easier to, more likely to bring. The other two classes, very similar. Okay, basically what you will have is, first of all, you still have a reference to the weather data over here. And then before the display, you also have to call updates, right? Inside the updates, you also have to get to the weather data, which is a remote communication, right? Similar. And not too surprisingly, for the third kind of app, you also have to do such thing, right? So kind of similar structure, similar. Again, you have to, again, initiate a reference to the weather data, and then you have to updates, and the update itself is going to be, again, a remote procedure call, right? And then before display, you can say updates, right? Basically, do updates every time before you do display. Let's do a very quick test to convince you, and then we can move on to observer, okay? So now let's look at this particular code. I'll show you the code very quickly, and then we'll trace it, okay? Only at a high level, okay? We don't need to go too much detail. Let's say this. We have line number 3, we got 3 local variables. We got current conditions, we got forecast, we got statistics. We got 3 instances of the app. I also got a weather data, a single instance. What we'll do is, number 1, we'll say, create a weather data. Let's say currently it's simply, you know what, I forgot the order. Basically, one of, maybe, I forgot. Anyway, look it up. So 9, 75, and 25, right? One of them is temperature, the other one pressure, and also humidity level, okay? Anyway, it's there. And then we're going to create the 3 apps over here, okay? We create instances of them. And now let's see this. When I say set measurements, it's like a change measurement, basically. I'm changing from 9 to 15. I'm changing from 75 to 60. I'm changing from 25 to 30.4. So now, is it necessary to call updates? It is, right? So now, if I say display, so line number 11 is necessary, which means when you call the display, it's also going to call updates. So far we're okay. However, let's say after displaying this, a few seconds later, we call display again on the same apps, on the same weather data. Line number 12, basically we're just saying that we periodically call display on the app. Line number 12, is it really necessary to call display? Now really, because the measurement hasn't changed, right? And then, after line 14, so now if we call display again, so it will be necessary again to call update, right? So the idea is you want to have a way to say every time if the measurement, like in line number 10 and line number 15, line number 10 and line number 14 are changed, somehow we can automatically notify all the apps that actually depend on this particular weather data instance. That's the insight. Do you kind of see what I mean? Okay, if you see what I mean, then you now have the motivation for observer. Let me just illustrate one more thing, okay, before we go to observer. Okay, that's just a code. I'll just give that here as a reference. Okay, so now, without going too much into it, I just want to say this. Okay, so now you can see that over here, this is when we try to change the measurements. So this means after this, apps must updates. So that means this particular line is okay. It is necessary. It's not really wasting any resources. On the other hand, when you try to call display over here, so these are kind of wasting resources because there's no change. Okay. Unnecessary updates because no changes on the measurements. Okay, I think that'll be enough. Any questions? Yes.
So you know how you said like you don't need the second line because nothing's been updated?
Mm-hmm.
So instead of calling the displays after every time we set measurements, you know how like, for example in Verilog there's like a feature called monitor where you monitor a variable and you only do something when that variable changes? Is there something similar like that in IFO?
I'm not too sure about the monitor variable. It could be something similar, but basically, I tell you what the point is. The point is somehow whether to update or not should not be up to the app. Whether to update or not should be up to the weather data. So weather data know when they should update, right? So basically think about when the weather data makes some changes on the measurement, they should know who to notify.
Okay.
So there should be like a subscribe and notify relationship over here. Right?
It's like only when each individual value changes, it'll call that class of display specifically.
Correct. Oh, Niwa, I have an analogy for you. Analogy would be, you don't necessarily have to email to the York University registrar office for, is there any updates today? Is there any updates about my degree requirement change? Is there any update on the exam schedule? You don't have to. What they would do is they maintain subscribers who are current students. Whenever there's an update from the registrar office, they would notify all the users that have been subscribed and tell you there's an update. You don't have to email them. That's an analogy here. If that makes sense to you, okay? If it doesn't, that's okay. Yes, question.
In terms of the intuition for the, let's say, not the subscriber, let's say for the metadata,
Mm-hmm.
do we have to implement the notion of state to like for the event? To, for example, if the state has been changed, then we push out a notification.
Yeah, basically, what we will see is when we get to the observer pattern, which we'll do the next, you will see that somehow we will make the weather station itself taking more responsibility about when to notify those apps that actually are subscribed. That's something we'll see. All right, are we okay with the first design? Okay, basically you want to know what's the criticism. So now let's go to observer. Again, we're going to look at, in general, how the observer works, and then I'll give you an instantiation of the observer pattern to the weather data station. Okay, you can also download the diagram on the website. That's clearer. Okay, so now observer pattern is going to solve this problem here that we talk about because every time there's an update from the weather, first of all, let me introduce terminology. There's something called subjects that's being monitored, like what you say, monitor variable, right? And also observer that who observe certain subjects, basically. Okay. So now let's look at the types over here. Again, polymorphism, dynamic binding should be in the play. Should be, okay? A subject over here, we have basically a list of observer. Of course, if you like, you can also make an iterable of observer. That's also fine, okay? And then you can think about observer over here is the static type of every observer. When I say it's a static type, that means dynamically it could be any of the descendant classes of observer. Guys, do you follow me? Okay, let me say again. You can see over here we declare observer to be of type observer. This observer over here is referring to the observer over here, which is deferred. So that means any class that is a descendant of observer can be dynamic type. Again, this list is polymorphic, right? We keep talking about polymorphic collection. It's really so common when you talk about design patterns. Okay, and then that's really important because that means you can subscribe different kind of observer, right? You can subscribe forecast, you can subscribe statistics, etc. So now the next feature is also very important. Okay, again, sorry about the resolution on the screen. Okay, in case you want to review, you can look at the recording if necessary. So this, I'll read it to you. The most critical command to implement is called notified, meaning that the subject, like a web editor, should know when to notify the user about updates, right? In that case, we'll look at the code in a moment. The post condition of notify is saying every observer in the observer, I'll make it bigger. Every O, like observer, after calling the notify, they should be up to date with the subjects. So this name over here is just conceptual, meaning that after you have notified all the observers, then they should be up to date. For example, pressure should be up to date for the forecast app, right? Okay, more to the pattern would be, so of course, subject itself can also got descendant classes, that's also fine, okay? And then observer can have descendant classes as well. So now what about the observer part? Okay, let's see. Also, you can see that put it into different cluster. One is called subjects, the other one is called observer, different cluster, okay? Let's see the observer side. The most important feature is called updates. You can see update here is deferred, meaning that at the very general observer level, I don't necessarily know how to update this particular observer. What about how do we apply this to the weather station? I'm going to show you anyway in the next slide. How does that apply? Does each kind of app update in the same way or different ways? Different ways, right? Forecasts only care about pressure, whereas other things care about other things, right? So now update is deferred, and then we're going to make it effective over here for individual ones, okay? And then up to date, that's something you can declare as like a query, okay? That's about the architecture for observer in general. Any questions? But in the next slide, we're going to see how to apply this to weather station. Hopefully, they're even clearer. Okay, we're going to reinforce that. Questions? Yes.
Between the update feature and the up-to-date subject feature?
Sure, no problem. You can think about what's happening over here is, what I didn't really put in the diagram was, after updates over here, first of all, you can see up-to-date with the subjects over here is used. It's like a query. Basically, we're saying that after calling the updates on each observer, they should be up to date. Okay? And then you can think about this post condition, which I didn't put over here. It would be, let me put it here. It would be ensure, okay, it would say up to date with subjects. That's implicit over here. Okay. All right. Let's now have a look at basically the same observer pattern, but being applied to the weather station. Okay? Still less complicated than visitor, I guess, right? But similar. Okay? Let's see exactly what's happening over here. Again, we have subjects and we have observers, right? We got two different clusters. Okay? Okay, we got subject over here, and then we got a list of observers. Observer is here. Observer, you can see, is a static type. And then it's here. Dynamically, it can be either forecast, it can be current conditions, it can be statistics. Okay? And then notify, the same as before. We're going to see exactly how to implement notify. And also update is the same. We're going to see that as well. So you can see that basically notify update here being deferred. However, in the forecast, update is going to be implemented in a way. And also in the current condition, it's also going to be implemented in a way. Okay, similar. And then weather data over here is the particular subject we're talking about. Okay, we can simply reuse the code about observers and notify. That's what we can do. Okay, so weather data, just the concrete subject we have. So here we got temperature, we got humidity, we got pressure, and also we got the invariance that we talk about. What's important is to see the client-supply relationship. Okay, let's see the one that's at the bottom there. So now we can see, first of all, you can see we have, from forecast, we have a client-supplier to weather data. So that one pretty much corresponds to what we said before, a few slides ago. Like, from forecast into weather data. That one's the same. Okay? That one hasn't changed. Okay? Just want to remind you. And then from current condition is also a client of weather data. Also statistics also is a client of weather data. Okay, the same as before. The thing that's new is over here, attach and detach. Okay, that's something we'll see. In the subjects over there, somehow we're going to need to attach an observer. Or you can think about attach in case you're not comfortable with the terminology. Attach simply means either to add or to subscribe. And when you say detach, it means to delete a particular observer. Once you detach a particular observer, the next updates will not be notified for that particular observer. Delete or unsubscribe. Okay, we'll see the detail a little bit later. Guys, any questions up to now? Okay, so now let's see a little bit code, a little bit, and then have some discussion. Okay. Okay, still about the first design. You can read it. Okay, so now sometimes people like to talk about observers being subscribers and also subject being publisher. Okay, just a different terminology. You might see a different context. And then when you say subscribe, it can be called attach or register. Okay, and then unsubscribe is also detach or unregister. Right, just different terminology. Publish is also notify. Okay. Okay, let's see a little bit code over here. Let's see for the subject, and then I'll let you fill in some blanks together. Okay, I think that might be good practice. I got about maybe 2 or 3 minutes. Okay, before the end. Let's say observers. It's simply going to be a list of observers. Let's say for the make, that means initially we're going to initialize an empty set of observers. What should be the post condition here? How do we make sure the observer is empty? Observer is empty? Yeah, sure. Or observer count equals 0, either way. Let's say we try to attach. Given some observer over here, we want to add it to the observers list so that the next updates we have, we can notify them as well. Okay. Now in this case over here, required to make sure we don't double attach the same observer. What should we write here? Not observer.so. Okay. And in short, will just be the opposite, right? Now you have it. Okay. Of course, if you really like to be complete, I didn't really show the complete detail. You can also try to do another one, others unchanged, right? Think about how you would do that. Think about it, okay? And then detach will be similar. I wouldn't bother you, okay? Similar. Notify is very important, okay? How should we implement that? I agree. We should have a loop. Let's say we have a cross loop. Let's say across observers. Yes. Okay, and then? And then update on each. Can you tell me exactly what to write? If you can tell me. Before I go back to the details, I want to get this right. So we talk about basically notify here, right? Basically notify for weather data. Actually, sorry, over here, notify. Okay, I'm talking about this particular thing. Okay, I would say across. Oh, actually, are you able to see at the bottom here? Okay. What I would do is class subjects. And then we have observers. Observer. And then we have over here notify. And do, and then also end. So Michael, suggest what I should write. Okay. Yes. As cursor. Either cursor or is something, right? You know, how about we use is? That might be a bit easier. Is observer. Yes. And then loop. And then you do observer.update. And that's it. Okay. Is everybody convinced that should be the implementation? Why would this work at a runtime? Dynamic binding. Given that the list of observer is polymorphic. Let me just show you very quickly, and then we'll continue next Friday. Okay, let me show you very quickly. At a runtime, observers is going to be something like this. It's going to be a list, let's say only 3 elements. Maybe the first one is simply forecast. And the second one is statistics. And the next one over there is condition. They're simply dynamically different types. They are polymorphic. So now, when I say observer the update, depending on which iteration I'm talking about. For the first iteration, I'm talking about this particular dynamic type. So now it's going to call the updates from forecast. For the second iteration, I talk about a different dynamic objects over here. It's going to call the updates from statistics, right? The third one is going to call from current condition. Okay, dynamic binding. Okay, make sure you know how this works. That's really important. Okay. All right. I think I'll stop here. Okay, about the lecture.